Binary tree level order traversal. Given the root of binary tree, return the level order traversal of its nodes values, that is from left to right, level by level. So basically this is binary tree level order traversal. That means in this question they are asking us to traverse in a level that this is level 1, this is level 2, this is level 3. So they need an answer, like they need from this level order traversal, we get 3. From this level order traversal, we get 9 and 20. From this level order traversal, we get 15 and 7, right? So they need this answer in the form of a level. So you just have to traverse in a level order way and give the answer. So for this, we can use a data structure, which is a queue. Why we have to use a queue? Queue data structure basically is having first in, first out, first in, first out. So in this data structure, we can say that if this first node is in, this first node will be out, right? This is the way. Let me explain you level by level. So how can we do this? We have to create one result list, list of list. That is because if you see the answer which they have provided, they have this one list and they have this outer list, right? They have the 3 920 are in one of their list. These are the inner list, and these are the inner list which you see these brackets, and these are the outer list. You see another bracket over here, and here also there is another. So our list will be list of list. Okay, this we will create as our one of the data. You can say a data structure. We can create a list of list integer with result array as a new array list. Next, we can create a queue, and in the queue, how we are going to do it is, so suppose this is a queue data structure. Okay, so first 3 will be in. Okay, the 3 will be in, and then we have to go to its left child and it's towards the right child. So when we are going to the left child, before that we have to remove this 3, and we will remove this 3, and then we will put it in another list, which is this inner list. We will put it in an inner list which we will call as a level, just a level list, and I will add the 3. And once I remove it, then I can insert 9 and 20. Because this is level order, so we have to insert it in a leveled manner. Now, when I insert this 9 and 20, I will have to again remove 9. Sorry for the disturbance. I'll again have to remove 9. So, before removing 9, I have to check their children's. But there is no children towards 9. That's the reason we can just remove simple 9. And then in the level, I'll add again a 9. Then we'll come to 20 and we'll see, is there any children? Yes, they are. Children's are there. That is 15 and 7. There are children. So you have to first go to the left side and check. Yes, there is a left child over here. So I remove 20. I add 20 in my level, and at the same time I'm adding the children, which is a left child 15 and 7, which is a right child. Once I add this, again I will go on 15. I'll check, is there any child? There is no child. So I remove 15 again. I remove 15 again, add it in my level. I check in the 7. Is there any child? There is no child. I remove 7 again and I add it in my level list. Once I add in the level, now this level will be added to our result list, which will help us to give the answer in this format which they needed. They needed a list of least integer because they need this two list. So our answer will be 9 comma 20, 15 comma 7. Yeah, we'll get an answer in this format after adding this level list in the result format. Now this process we are just traversing once. Queue data structure doesn't take much space about it. So time complexity wise it is O of n, and the space complexity is also O of n. Let me show you in a coding format. We have to return it in list of list format, right? So let's start this public list of list integer, because this is we want to return it. So let's do it. Binary level traversal, binary level traversal, TreeNode root is given. Let's initialize our result which I showed you in the diagram. So I'm initializing the result list equal to new array list. Once this is done, our edge case is if root equal to null, then what we are going to do it. If root is null, we are going to return the result as it is. Whatever the result is there, we are going to return it. Next there is next we have to create initialize a new data structure, that is of queue data structure with TreeNode queue equal to new linked list. Uh, I will add the root first, as I have shown in the example that I'm adding the root first. Q dot add root, and then we'll start after checking that queue is not empty. If queue is empty, then you are just returning the result, right? So we have to have this check, because otherwise there will be an exception. So I will be checking while queue is not empty. What we are going to do, we are going to iterate the binary tree. How to iterate it? Just a for loop on int of I equal to 0, I is less than q dot size I plus plus. Okay, we are iterating the queue, sorry, we are iterating the queue, and because here we are adding in the root inside the queue, then we are checking queue is not empty, so there is a value in the queue. We are iterating the queue, whatever is the first value we are going to add it into the level list. So we have not yet created the level, so we'll just initialize that also. Level equal to new array list, and then we are going to say TreeNode current, TreeNode cur equal to queue.poll. So the first one we are just polling it out, and then we are adding it into the level, right? Once we poll that, we are adding that into the level. So I'm just going to add cur.val, because val is the value of that current tree node. Next, I'm going to check the children's. If dot left is not equal to null, then what we have to do, if it's not null, if it's null, then I don't have to check. If it's not null, then I just have to add it into the queue dot add cur dot left. Same goes with the right side of the tree node. I'm checking here also that if right is not null, then I'm just going ahead and adding it in my queue, and then in the result I'm adding my entire level list. And you are returning result and not the level, because they need it in list of integer, so we have to return with result. And this entire thing takes O of n, because we are just traversing once, so time complexity wise it is O of n. We are traversing once and just adding it to the queue and polling it out first in first out, which is a queue data structure. So it is just O of n time complexity, and space wise is also O of n space. Thank you.